Here's one. This one is converting units within type 2. So from mass percent or percent by weight, you want to calculate molality, parts per million, parts per billion, mole fraction of HCl, and mole fraction of water. So concentrated hydrochloric acid solution in the lab, you'll find it on the label. It says it's 37% by mass HCl. The rest of it is water. Okay. What would be the molality, the parts per million, parts per billion, and the mole fraction of hydrochloric acid, and how much the mole fraction of water? So percent by weight. So what would be a good number to assume there? Anytime you have percentages, you can assume 100 for the whatever the denominator is, right? So you assume in this case, and like I said, it doesn't matter what you really assume, because when you take these ratios, you end up with essentially the same number. So you have to assume in this case you have 100 grams of solution. Okay. So what would be the mass of the HCl? 37 grams. How would be the mass of the water? 63 grams. Okay. How do I calculate molality? What's the definition for molality? Remember, HCl is your solute, right? And your water is your solvent, right? So molality of HCl is moles of HCl, which is our solute, right? Divided by kilograms of water, which is our solvent. Okay, can we calculate moles of HCl? How do you change 37 grams to moles? 37.0 grams HCl. Change it to moles. 1 mole HCl is how many grams? H is 1.008. Chlorine is 35.45. So it's 36.46. So HCl is 36.46 grams per mole. Okay. So that gives you moles of HCl in the numerator. How many kilograms of water do you have? Right here, 63 grams. How to change that to kilograms? How do you go from grams to kilograms? You want 1 kilogram equals, kilo means 10 to the third, right? So 1,000. A kilogram is 1,000 grams. Okay, so that cancels grams. So our molality is equal to, how would that be? 37 divided by 36.46. Did I record? Yeah, I am recording. Okay, 36.46 equal, what did I just do? Okay, clear. Okay, it's 37 divided by 36.46. So that's 1.014 in the numerator. Okay, 1.0148, so 1.015. I'm keeping an extra digit there. I should only have 3 sig figs, right? Divided by, what's my denominator? .063, or my denominator is 0.0630 kilograms, 3 sig figs. So this is equal to 1.015 divided by 0.063, 16.1 molar. Okay. mole per kilogram. So the molality is 16.136 base. All right. Now, you remember last time we said concentrated HCl is 12 molar, it's 12 moles per liter. So the molarity of concentrated HCl is 12, the molality is 16. Okay? So it's moles solute per kilogram of solvent. So can you do parts per million? That should be easy, right? How do you do parts per million? Mass HCl over mass total times what? A million. Instead of times 100 to get the percent, you get times a million, right? So ppm, I'm sorry, would be 37 grams HCl, okay, over how many grams total? 100 grams total. Okay. Times 10 to the 6th. Okay. That will give you ppm. Okay. 10 to the 6th. How do you get mole fractions? Mole fraction of HCl would be moles HCl over moles total, right? So moles total is moles HCl plus moles water. Again, how do you solve for moles HCl? 37.0 grams HCl. How many moles? What's the molar mass? 1 mole of HCl is 36.46 grams. Okay. So again, this is 37.0 over 36.46. How many moles of water do we have? Your water is 63 grams. So 63.0 divided by 18.02. Okay. That would be your mole fraction of HCl. So converting within the same type of concentration units should be pretty straightforward.